Good morning, everybody. Today I'm going to show you how to reduce square roots. We're going to need to use this tool to help us when we get into the next method of solving quadratic equations by what's called the square root method. So we need to practice reducing radicals. Everybody should have their half sheet perfect square numbers on there. If you lost yours or can't find yours, you can always find it in Google Classroom. I have copies there being listed in your Chapter 9 materials. I'll post one in there for you. And otherwise, I'll just put a list of perfect squares here on the side that we could use. You could write this in your notes as well. These are the first 12 more common ones that you're going to see used. Remember, if I asked you what does 25 come from, you'd say 5. So those are the perfect squares. All right, so perfect square numbers. If you see numbers like this, these are super easy. First one, square root of 16. What does 16 come from? 4. Done. Square root of 25. What does 25 come from? 5. Done. Some of them that you're going to see on your worksheet are going to be really, really easy to do, just like these two. Now, some of them are going to have to be broken up into factors, what multiplies together to give you these numbers. If you don't have a number that's on your perfect squared list, then what we have to do is think of numbers that multiply together. You want to pick the pair that will work. So if we do the square root of 18, and I ask you, tell me numbers that multiply to give you 18, you could say 1 times 18, but is either 1 or 18 on this list over here? You could say 6 times 3. Do you see 6 or 3 in your perfect square list? No. 9 times 2. Yes, 9 is right there. So you always want to pick something that is on your perfect square list. So the way we're going to reduce these is to make two little branches. So instead of 18, we're going to write it as square root of 9, square root of 2. Put each of those numbers underneath the square root sign. And then tell me the one that you know. Square root of 9 is on your list. It comes from 3. If you cannot reduce the square root of 2, 2 is not on our perfect square list, drop it straight down. Oops, 2, sorry, 2. So your answer reduced is 3 square root of 2. And you're going to hear me say 3 root 2, just as kind of a shortcut way to say it. So we're trying to reduce radicals. This is our goal, reduce radicals. We're trying to make them into simplified form. All right, let's try 28. Tell me some numbers that multiply together to give me 28. What? Can't hear ya. Okay, 1 times 28. What else? What? Speak up. 7 times 4. What else? Yes, 14 times 2. Which set has a number that's on your perfect square list? Yeah, 7 and 4. So we're going to branch and do square root of 4, square root of 7, and 4 is on your list. What does 4 come from? And drop down to square root of 7. 2 root 7 is your answer. You know that you're done when you look at the number that's underneath the radical sign and there's nothing else that you can break it apart as that has a perfect square in it. 32. Think of all the numbers you can think of that multiply together to give you 32. 1 times 32, 2 times 16, 4 times 8. There's a couple numbers that are on that list. You could pick 4 times 8. 4 is on your list as a perfect square, but do you also see 2 times 16? If you have two choices, you always have to pick the biggest choice. So for this one, we have to use 16 and 2. 16 comes from 4, drop down the 2. Answer. 56. What do you think is going to work for 56? You might think 7 and 8 and stop there. but 7 and 8 are not on your list. There is something that's a perfect square. You might have to look at your times tables. If you look long enough and hard enough, hopefully you'll find 4 times 14. So that's how we're going to break this one up. 4, 14. Square root of 4 is 2, and 14 dropped out. 14, if you think, but I can keep going. The only thing that multiplies to give you 14 is 2 times 7. Do you see either 2 or 7 on that list? No, then you know you're finished. So the answer is 2 root 14. Here's a new one for you. Anytime you see a negative number under the radical, that is not a real number. It does reduce with radicals. So the way we're going to break that one up with our branches is to remember this rule right here. The square root of negative 1 is always equal to the imaginary number called I. So if you see something like the square root of negative 81, we're going to break that apart automatically, take out the negative 1, and then do your 81. 81 is on our list. What does 81 come from? Yeah, 9. So each one of these is now a perfect square. The square root of negative 1 is I, and the square root of 81 is 9. This is backwards. Remember, we like the numbers to be in the front, so I'm just going to change this around. 9i. There's my answer, 9i. Square root of negative 12. Okay, square root of negative 12. Here's our numbers again that we like to use. I'll stop there. We're going to have to break this one up. I'm going to actually make 3 branches. Because I've got that negative sign, square root of negative 1 automatically takes one of those branches. All right, now tell me 2 numbers that multiply to give you 12. You could do 1 times 12, you could do 6 times 2, you could do 4 times 3. What is the set that we have to use that comes on our list? Yeah, right. We have to use this one, 4 and 3. Square root 4, square root 3. So now I have 3 pieces. I can actually answer 2 of them. The square root of negative 1, I. Square root of 4, 4 comes from 2. And I have to drop down the square root of 3. So do you think this one's written forwards or backwards? Does it look funny to you? I, 2 root 3? It looks funny to me. 2i root 3. We'll do that. 2i root 3. Okay, have a couple more, and then I'll let you go ahead on your worksheet. 64. Is 64 on our list automatically? Hopefully you're remembering these numbers. 64 comes from 8. Yep, so I can do 2 branches, give the negative 1 its own branch, and I can leave 64, and I can do both of these numbers. Negative 1 comes from I, 64 comes from 8, flip it around, 8i, done. 32, 3 branches, negative 24, 3 branches, negative 44, 3 branches. What's the first branch in every single one of those going to be? Negative 1, negative 1, negative 1. What's the answer for the square root of negative 1 every time? I. All right, now we need to think of our numbers again. Each of these numbers you've probably been seeing a lot show up. What are the 2 numbers that we're going to take for 32? Remember, you want to look for the biggest perfect square that you can. Maybe you remember we did this one earlier. We're going to use 16 times 2. 4 and 8 would work, but you'd have to do the reducing again, so pick 16 and 2. What does 16 come from? 4. Drop down the square root of 2. And then flip it around so it looks good. 4i root 2. 24. What are your 2 numbers you're going to use for 24? 6 and 4. That's the only one that's got a perfect square. 4, square root of 4 comes from 2. Drop down the square root of 6. Make it look nice. 2i root 6. Guess what goes into 44? Hopefully you can think right away. 4 times 11. What's the square root of 4 come from? Drop down the square root of 11. And does that one look nice? No, make it look pretty. 2i square root of 11. You're good to go. Okay, your practice worksheet is titled up at the top, 9.7 Simplifying Radicals Worksheet. Okay, use your list. I would suggest you put this right on the top. -1, square root of -1 equals I, and you also might want to write this list right down the side. These are the most common first perfect squares that you could see that you might have to break apart things and then try to pick out numbers that are perfect squares. All right, good luck. We'll see you next time.